These are the questions from trigonometry board exam type for class 10th. Question is evaluate 3 sine 30 degree minus 4 sine cube 30 degree upon 2 sine square 50 degree plus 2 cos square 50 degree. So I have written the same expression over here. Now sine 30 degree is 1 upon 2. Okay. So we will put the value 3 into 1 upon 2 minus 4 into 1 upon 2 whole cube divided by 2 into, because 2 is common, so sine square 50 plus cos square 50, and this is nothing but sine square theta plus cos square theta. So in the next step, 3 into 1 by 2 minus 4 into 1 upon 2 whole cube, so that will give you 1 upon 2 whole cube. So 4 into 1 upon 8, and this will give you 2 into 1. Okay, so 4 and 8 will get cancelled, 1 upon 2. In this way, 3 upon 2 minus 1 upon 2 divided by 2. So you will get, this will give you 2 upon 2, 2 upon 2 divided by 2. So 2 and 2 gets cancelled, 1 upon 2. So this is the value. Now the next question is, let x and y be two distinct prime numbers and p is equal to x square y cube, q is equal to x y 4, r is x5 y square. Find the HCF and LCM of PQ and R. Further, check if HCF PQR into LCM PQR is equal to P into Q into R or not. Okay. So two things you have to do. First find the HCF and LCM and then check whether their product is equal to the product of the given numbers. So P is x square y cube, Q is x1 y4, R is xy y square. Now HCF of PQR together is nothing but product of the lowest power of common factors. HCF is nothing but product of the lowest power of common factors. So what are the common factors among P, Q and R? One is the x, and x, lowest power of x among these three. This is 1, this is 2, this is 5. So 1 is the lowest power. So x1 and its product with another common factor, y cube, y4, y square. So y square, smallest power of the common factor. So this is your HCF. Now LCM is PQR is, according to the definition, LCM is product of highest power of all the available factors. Okay, whether it is common or not, that is not the point of interest. Any factor which is available either in P or in Q or in R or in all the three, any of the two numbers, all those factors will be taken into consideration with their highest power. So check, x power is 2, x power is 1, here x power is 5. So highest power of x is x to the power 5 among P, Q and R. Okay. Similarly for y, power is 3, y 4, this is 2. So highest power is 4. So this is the product. Now you have to check, this is the LCM and LCM you have got. Now product of HCF PQR into LCM PQR is, according to this, x power 1 y square into x power 5 y power 4. So x6 y6, and PQR is this, this and this products. So x square y cube into x1 y4 into x5 y square. So it will give you x power 2 plus 1 plus 5, that is x power 8, y power 3 plus 4 plus 2, that is 9. So you can see they are not equal. This is x power 6, y power 6, this is x power 8 and y power 8. So HCF of PQR and LCM of PQR not equal to PQ and R products. Okay. However, one tip I would like to add over here, this relation holds true only for any two numbers at a time. Okay, means what does it mean? Means HCF into LCM is equal to P into Q. Okay, any two numbers, here PQ and this is also P and Q, means HCF of any two number into LCM of any two number is equal to the product of the two numbers given. Okay, it is not true for the three numbers at a time. So this we can verify by the same example. P is x square y cube, Q is x1 y4. So HCF of PQ is common factors, that is x power 1. and for y power 3. So this is your HCF. LCM is highest power of the factors. So x highest power is 2, y highest power is 4, so they are products. Now find this HCF of PQ and LCM of PQ is x power 1 y power 3 into x power 2 y power 4, that is x cube y 7. And PQ original products x square y 3 and x1 y 4, so x square y 3 into x1 y 4, x cube into y 7. So in this way you can see that these two products are same, so this relation is true. Now similarly it can be proved for Q and R. You can take the Q and R as a pair and P and R, and you can try it. Okay, thank you.